In this video, we will explore one of the prominent clustering analysis methods, which is the k-means clustering method. The content related to k-means clustering analysis is divided into two parts, theory and coding, spread across two different videos. In this video, we will focus on implementing the k-means clustering method through coding. For the theoretical part, you can refer to the previous video. We'll now attempt to implement the k-means clustering analysis through coding. The Jupyter Notebook file for this can be found on GitHub, and you can download it to execute it yourself. To perform the coding here, we'll start by importing libraries such as NumPy for numerical operations, Pandas for data manipulation, and Matplotlib for plotting graphs. Additionally, we'll import libraries like k-means, Silhouette_score, and Silhouette Visualizer for k-means clustering analysis and visualization. For this exercise in cluster analysis, we'll use a synthetic dataset provided by scikit-learn called make_blobs. Here, n_samples indicates the number of data points, and centers represents the number of clusters. Setting n_samples to 500 and centers to 5 will generate a virtual dataset with 500 data points distributed across 5 clusters. As a result, we'll have a total of 500 data points, with 100 points in each of the 5 clusters. If we print the x and y data for the first 10 points, you'll see the coordinates along with labels indicating which cluster, 0, 1, 2, 3, or 4 each point belongs to. In the NumPy library, you can use the unique command to remove duplicate values and display them. The y data contains a total of 5 values, which are 0, 1, 2, 3, and 4, representing 5 clusters. To visualize this in 2D, you can use a for loop along with NumPy's unique function. So, by inputting 0, 1, 2, 3, and 4 into variable c, you can represent each cluster on a graph. Additionally, you add 1 to these values to display a legend with 5 clusters. Even by a simple visual inspection, it's clear that the generated dataset has been well divided into 5 clusters. Assuming that these 5 clusters represent the original data, you can practice cluster analysis by comparing the results of your clustering analysis with this original data. This will help you determine how effectively the cluster analysis is working. As explained in the previous video, in k-means clustering, we predefine the value of k, which represents the number of clusters. In this case, we have set it to 5. Next, for the method of initializing the cluster centers, we have chosen the k-means ++ method. Then, we perform cluster analysis using the x data. As a result of this cluster analysis, you can see that the data has been divided into a total of 5 clusters, labeled as 0, 1, 2, 3, and 4. When you visualize this by assigning different colors to each cluster in a 2D plot, you can clearly observe that 5 distinct clusters have been well formed. Furthermore, as explained in the theoretical section, in k-means clustering, we need to predefine the number of clusters. To determine the appropriate number of clusters, we can use a method called the silhouette score. By calculating the silhouette score for different numbers of clusters and plotting it on a graph, we can make an informed decision. In this case, we calculated the silhouette scores for cluster numbers ranging from 2 to 13. The results are displayed in the graph below, with the number of clusters on the x-axis and the silhouette score on the y-axis. As you can see, the highest silhouette score is achieved when there are 5 clusters. Using this information, we can explore how the data is clustered when there are 5 clusters and visualize it by assigning different colors to each cluster. The outcome shows that setting the number of clusters to 5 results in well-defined clusters. As mentioned in the theoretical section, the silhouette score measures how close each data point is to its own cluster compared to neighboring clusters. A silhouette score closer to 1 indicates that data points are closer to their own cluster and farther from neighboring clusters, suggesting better clustering performance. Therefore, by using different colors for each cluster as shown below, we can easily visualize the silhouette score for individual data points within each cluster, as well as the overall silhouette score for the entire dataset. This allows us to assess how close the silhouette score is to 1 and provides a visual way to understand the quality of the clustering results. This slide presents the results for different numbers of clusters, specifically 2, 3, 4, 5, and 6. The y-axis represents the clusters, and the x-axis represents the silhouette score. You can also distinguish between clusters using different colors on the graph, and the red dashed line represents the average value of the silhouette score. When there are 2 clusters, you can see that the average silhouette score is less than 0.6. For 4 clusters, it's around 0.7, and for 5 clusters, it reaches approximately 0.8. However, if you increase the number of clusters beyond 5, the silhouette score starts to decrease. A higher overall average silhouette score with lower variability within individual clusters indicates better clustering analysis. In other words, when there are 4 clusters, you can see in the red section that there is high variability within individual clusters, which is not indicative of good clustering. However, when there are 5 clusters, you can observe that the overall average silhouette score is the highest, and the variability within clusters is low. Therefore, selecting 5 clusters appears to be a valid choice based on this analysis.